Okay, we're going to continue with the routing protocols for the ICND2. We did RIP v1 and RIP v2, and ICND1 and OSPF and EIGRP are the ones that are the routing protocols for ICND2, and they're a lot more sophisticated. EIGRP and v4 for IPv4 obviously is the first one we're going to cover, and it is I've heard described the best routing protocol ever developed. It is an enhanced version of IGRP, which was in one of the earlier slides last night, and it was the one that said we don't use it anymore. It's gone. But this is an enhanced version. It was an every 90-second update. Had 100 hops, I think, or something like that, and took a long time to converge. EIGRP is called a hybrid protocol. What it really is, and when you answer questions for CCNA, it's a hybrid protocol, but it's really an advanced distance vector protocol. It uses multicast, doesn't use broadcast. It is the one protocol that actually keeps the topology table in it. It keeps a backup route available in the device. I think maybe what we could do, hopefully what we could do here is to just do some looking and some demo before we start. I've got a couple of them here, and we'll talk about some terms as we go through this. These are on the serial links. I want to look at a couple of them. I want to look at this one down here first, this router 0, because we have two, and these are two equal cost links. And the reason is we've talked about equal cost. We can do that. You can have equal cost or unequal cost in EIGRP. When we look at this, and I've already done the show IP route, here we show that we have two routes via two different locations, via the 11.1 and the 10.2, via hopefully the 11.1 and the 10.2. We've got the 11.1 here, which is gig, and the let's see, the 10.2 here, which is gig 02, and that works out gig 02. We have a couple of tables, multiple tables actually in this. If we go into the show IP EIGRP question mark, we can show the interfaces, and this is a quick way to see which interfaces that EIGRP is activated on. It's got to be activated on the interface before it plays in the game. And then we can show EIGRP. I did instances. Let's go back and other things that we can look at here. Neighbors. For this one, we have the neighbors 11.1 and 10.2, the two other routers that are available there. These over here, these numbers just represent the order that they became neighbors in, and then the whole time, 11 seconds, 14 seconds, whole time is how long it'll wait before it thinks that that neighbor is no longer there, and these whole time are staying the same. And how long? 24 minutes. Smooth. I forgot. Anyway, how the round trip time, smooth round trip time is what we're talking about here. But the thing that kind of sets it apart from the others is the topology table. When we look at it, it has successors, and successor routes are the ones that are successful in EIGRP. FD is called the feasible distance. The feasible distance is the cost to get to that location. And these down here have the same feasible distance, 2170112. So we're going to have two equal cost routes to get there. So both of them will be listed in the route table. This other thing here is called the advertised distance, and what this is the cost for the neighbor. And what I want to do here to force a change, that we've seen the equal cost, I want to take this link out, put a switch in here, if I can drag a switch up, put a switch in here and put it on a fast Ethernet instead of a gig connection. So if we connect our gig to a fast Ethernet, it's obviously going to revert to the lowest speed. So we'll put these on here. Take a few seconds, spanning tree in here. One of the ways that we can hopefully speed up spanning tree is go in here and do span tree, port fast, default, which should allow it to come up quicker if it will do that. But it's not going to do that for me, is it? So we're getting there, and these things probably are going to have to, and we're forming the adjacencies again because we lost the connectivity. So we're doing up. Dual is the algorithm that it uses, that EIGRP uses. So if we show IP, EIGRP topology, when we go down here, we now have one successor in the feasible distance 217.0.112, 217.0.112, which is going to be the one that's the gigabit. We have two of these two routes listed in here. This is what's called a feasible successor, a backup route. So that if this one goes down, the second route will automatically pick it up. And you notice the cost is not radically different from it, 217.0, 217.2, but the advertised distance is the same from each one. So the cost in the advertised distance, the second number is the cost from the next hop router, the advertised distance. So we have the one successor. If we go to the show IP route, if I can spell route, then we no longer have the two routes showing up in the route table. So the successor or the successful routes are the ones that show in the route table. The feasible successor is in the topology table. If the one goes down, the successor route goes down, the feasible successor is available to do it. And let's do show. I'm going to show IP protocols. I want to show a couple of things here about, and this is EIGRP 20 is going to be the autonomous system. I've got another router in here that's not been configured yet. So the autonomous system number 20, it's going to share its information with all of the routers that we have defined as autonomous system 20, and this is for an internal gateway routing protocol. We can assign them. For the external routing protocols, the autonomous systems are assigned to us. Redistributing EIGRP 20, which means that it's sending out routes for EIGRP 20. Autonomous system 20, the thing that you may need to know how to get to for certification are the K values. Only two of them are used, as you can see. They have to match. And these are the things, these are the multipliers that we use to create the cost or to determine the cost using the dual algorithm. And the slide, and we'll look at it in just a second, it's got the formula. It's a pretty complex formula. But what it really amounts to, the K1 and the K3 are the multipliers for bandwidth and delay. So that's the only things that it really uses. Maximum paths for the equal cost paths, 4. That is a configurable number in here, but the maximum of 4. And if you exceed 4, the ones that it's going to knock out are going to be based on the MTU. So the bigger MTU, maximum transmission units, are the ones that will stay, and the smaller ones will go away. Maximum path, maximum hop count 100, and variance here of 1. Variance is another configurable parameter that we can make different than 1. 1 says that there really is no variance, and that's what makes the equal cost automatically comes in. If we want to make it unequal cost, we would change the variance to maybe like 0.5, which would be 50%. It has to be at least 50%, within 50% of the best route in order to be there. And then the system will send, if we had like a 10 and a 2, it will send 10 packets on the 10 and 2 on the 2, 10 to 2 sort of arrangement. Routing for the networks that it's routing for, information sources, the gateways. The distance here, 90, is the administrative distance, and we talked about that, I think, in ICND1. It is the administrative distance, is how trustworthy is this route. Directly connected is 0. The most trusted has an administrative distance of 0. A static route has an administrative distance of 1. EIGRP 90, so it's going to be trusted there, and OSPF is 110, and RIP is 120. So RIP is the least trusted, which means that if we have both of these protocols running, the routes that are going to be displayed, or all of them running, the routes that will be displayed is going to be EIGRP, because it's the most trusted. The distance here, internal and external, 90 is typically the one you're going to see. That is the internal administrative distance. If it's an external EIGRP route, a different autonomous system, then it's going to be 170. It won't be as trusted as the other routing protocols. Did I? And then we have this at interfaces we looked at. Traffic just tells us what's going on, how much traffic is going on with it. So this router up here doesn't have any routing protocols on it. Let me see if I can go through and make a mess of this one. And if we do a show IP route, then we have our directly connected 192.168.10, 192.168.220. EIGRP has some kind of interesting aspects, characteristics, and when we start advertising it. If we use 0.0.0.0 for the network, and then 255.255.255 for the subnet mask, it'll advertise all of the interfaces. If we want to be more specific, we'll need to use a wildcard mask. T, and I think it was autonomous system router EIGRP, and then the autonomous system, I think, was 20, wasn't it? And then we can do network. Let's do 192.168.220.0 and see if it'll take that command, and it did. And then we could do the 10, let's see, 192.168.10. Let's just try 192.168.10.0, and then what it says is it wants the wildcard bits, and we could do the 0.0.0.255 is up and new adjacency. That was the interface, the network that connected to the other routers. So now if we go to show IP EIGRP neighbors. Yep, we have one neighbor, obviously, because we're only connected to one other one. Show IP EIGRP topology gives us the successors, the FD, the feasible distance 217368, which matches the first number in the via. The second number again is the advertised distance, which is what the next hop router tells us it costs to get to this network. So quick overview, a little bit about EIGRP and how to configure EIGRP. While we're here, we'll do, this is for, we did V4. These have 6 IP EIGRP for version 6 on here also. Just like OSPF, we go into the interface and we have the IP address, the IPv4 and the IPv6. IPv6 EIGRP 10. So it's Autonomous System 10. It is one of those things, and I think that, I'm sure that in here, yeah, for IPv6 EIGRP, we specify the router, IP EIGRP 10, we specify the autonomous system number. We give it a router ID. The router ID is a 32-bit number. Looks like a obviously looks like a an IPv4 address. And then you have to give for EIGRP, you have to give it a no shutdown command for IPv6 EIGRP to work. So let's look at these slides and get through them so you can get into the lab business. A hybrid routing protocol developed by Cisco Systems. Characteristics of both distance vector and link state protocols. Supports routing of many protocols across the enterprise network. And that is one of the differences with this than the other ones. Many protocols, which means we could do IP. If this thing will, it's not going to write for me tonight, is it? Oh, I did a good job there. It'll do IP, IPX if we still used it, Apple Talk, others, and that's what it means, many protocols. OSPF is an IP routing protocol because the Cisco proprietary can only be used with Cisco routers. And again, that is, I think Cisco has opened it up, but I don't think anybody else is using it. Uses periodic hello messages for neighbor discovery, discovers the neighbors, and then the whole time is how long it's going to wait before it gets an answer from a neighbor before it says, okay, you're not there anymore, I'm going to wipe out your routes. Learns a neighbor will send a one-time update of all the local EIGRP routes. That's where we get the advertised distance. And then we add the cost to get to the neighbor to the advertised distance, and that becomes the feasible distance, the cost to get to the destination network. Calculate the route distance based on the received metrics and locally assigned cost to link to that neighbor. Router EIGRP autonomous command, we did that to create the autonomous configuration, creates the EIGRP routing instance that can be used for tagging route information. EIGRP4 run over IPv4 networks, and again here we have the K value is what they do. K1 is bandwidth, K3 is delay. Those are actually were the only ones that had values of 1. The rest of them were 0, and these are the multipliers. These are not the bandwidth and delay. These are what we multiply the bandwidth and delay with, and you can find those with the show interfaces command. Show interfaces 0, 0, whatever, but the metric is 256. In IGRP, it was, this number wasn't there, it was just K1, so it's 256 times K1 times the bandwidth plus K2 times the bandwidth over 256 minus the load plus K3 times delay times K5 over the reliability plus K4. Again, relatively complex. We don't need to know how to do it. Just wanted you to see that. Yeah, there's a lot that goes on in calculating this one. This again are the components. K1, the bandwidth, and it uses the lowest bandwidth to calculate what's going on. Good. Uses the lowest bandwidth of the route. K2, the load, is 0. We're not going to worry about it. K3 is delay, is the cumulative interface delay of the route. So it looks at all of the interfaces in the route and adds those delays up, and that's again a factor of 1, so it is a value. Reliability is 0 and MTU is 0. MTU is really not used unless we have more than the default was 4 equal cost paths. If we had 5, then the one with the smallest MTU would not be used. So the show IP protocols will give you the K values. What I have seen and heard, and I've taken several of the CCNAs, they used to have, and I think they still have, an EIGRP troubleshooting problem, repair problem, whatever. The two things that you got to be aware of, I think, is that the autonomous system number is different, is the reason it can't, and the problem that I had that you may see in some of the test banks is you just added, or somebody, the junior administrator just added a router and it's not updating. What's the problem? Show IP protocols will show you the autonomous system number that's running on it. And it was a show interfaces, show IP interfaces, I think, was the one that, no, show IP protocols was the one that showed us what the K values were. The K values have to match and the autonomous system numbers have to match. And we have to have advertised the interfaces. When I did the demo, you saw that immediately when I advertised EIGRP on the interface that was connected to the neighbor relationship established with it at that point. EIGRP uses its own transport protocol, the reliable transport protocol. It does not use TCP or UDP. It uses RTP, reliable transport protocol, and you'll see the RTP used, the abbreviation used a couple of ways, but guarantees the ordered delivery of the packets. Hey, it kind of sounds like TCP, doesn't it? But it doesn't use TCP. It uses the RTP. Supports intermixed transmissions of multicast and unicast packets. It prefers multicast. If the multicast doesn't work, then it'll revert to a unicast. Neighbor discovery and recovery uses the hello messages from the RTP to discover the neighboring routers. These guys, once they share all of their information and we establish the route tables, the topology tables, and if we have unequal cost and we haven't changed the variance to allow unequal cost paths, then the feasible successor will be in the topology table, and that's one of the advantages of EIGRP over OSPF. OSPF, a link goes down, it has to go through the recalculation. EIGRP, a link goes down, it's got the standby route available and it can immediately take over. The information in the neighbor table include the neighbor address, the interface it was learned on, the whole time, how long it will wait before declaring a neighbor unreachable if it doesn't get another hello or doesn't get an answer to a hello. The wait time, and we saw that, the whole time is 3 times the hello interval of 15 seconds. The diffusing update algorithm dual calculates the information based on the destination networks in the topology table, uses the distance metric to select the loop-free paths, and we looked at some of those and the formula of what it actually uses to get there. And I think I've got another slide here in a couple minutes that shows that again. Auto summary, and there's been some, and I was confused for a long time because books say, okay, auto summary is enabled by default on EIGRP, and the answer is maybe. IPv4 automatic summarization is disabled by default on the new routers, beginning with iOS 15 and 12. Says iOS release 15.0 and 12.2 update 33. Prior to that, auto summarization was enabled by default. So you just got to look at it or look at the auto summary. If you don't want auto summarization, it never hurts to put in the no auto summary command that shows down there. Router EIGRP, no auto summary. Auto summary will automatically summarize SuperNet, for lack of a better word, routes at class full boundaries. So if we had subnetted a 10 network, 10.60 maybe, or 172.16 as a class C, when it will then automatically summarize the one to the 172.16 network address. If we don't want it to do that, we want to keep the networks separate. The no auto summary will do that. If you want auto summarization, then on the newer ones you have to give it the auto summary command. In order for that to work properly, you need to have be sure that you have configured a hierarchical IP addressing scheme so that auto summary works for you. An example, kind of, sort of that was at when I was at ECPI, the headquarters activity got was connected to all of the different 12 or 14 or 15 whatever physical locations, and we were all assigned network addresses, and ours was 10.60, and we used a 255.255.255.0 subnet mask. We used a class C subnet mask on the individual networks that were in the building: 10.60.200, 10.60.110, 10.60. whatever else, and we used the room numbers for the network addresses, so that one of those, yeah, it makes it a little bit easier to keep everything straight. But what that allowed the headquarters activity to do was to summarize the routes that came to Roanoke to 10.60 with a 255.255 subnet mask, so that everything that started with 10.60 came to us. Everything that started with 10.10 may have gone to Greensboro. Different things. When it got to the campus at Roanoke, we would then break it out with the class C subnet. So auto summary can work to your advantage. It can mess you up sometimes too. If you get a situation and these routes just don't look right, check to see if auto summary has happened to you. This is one that I found someplace, EIGRP terms, and hopefully we looked a little bit at that when we did the demo. Some of the things: the reported distance, the destination network, and the next hop address. So what that really amounts to is, if this is the destination network over here, and this is the next hop, and this is us, this guy, well, we'll start back to the destination. The destination is going to have some bandwidth and delay on its interfaces. So it tells this guy what its bandwidth and delay is. And that is the reported distance. The reported distance, reported cost might have been a better term, but reported distance is what the next hop device tells us its cost is to get to the destination. What we do here at the next hop is it adds these costs to the reported distance, and that's the feasible distance. The feasible distance between the destination and our router. The feasible distance is what it cost us to get there. The successor is the route with the least hop count and listed as the primary routing table. And instead of hop count here, let's say cost. And then it did have a hop count, as you saw when we did the show IP protocols. The feasible successor is a backup route. So, and we saw those when we put it in and made the one of them smaller than the other one. So we had the successor think successful, and then feasible successor is a backup, and I don't have anything for it, but feasible successor, it is feasible, but it's not a successor, it's not successful. If the successor fails, the feasible successor will take over. We looked at some of the tables. Selects the primary successor and the backup, the feasible successor routes, and injects those into the topology table, and we saw those in the topology table. The primary, the successor, will be moved to the routing table, and we saw that. So we have the neighbor table, the bunch of tables, and we looked at them. List of directly connected adjacent EIGRP routers is going to be the neighbor table. The topology table, all the routes learned from each EIGRP neighbor, identifies the successor and the feasible successor route. So the topology table has the routes that we're going to use and the backup routes in it. And then the IP route lists the successor, the best routes go into the routing table from the topology table. The other routes are still there, obviously, but they are not listed because they're not the best route when we get there. And here we got this one that we have I can reach 10.0 whatever here, this network with a metric of 25, and then it was 175 bandwidth and delay here. This means that my distance is 200. So this guy tells us what its cost is. We add the cost from us to the next hop in order to get our costs. Feasible distance and advertised distance on these, same thing here in a little bit larger scale. And then show IP route EIGRP. Dual is the EIGRP abbreviation. 1010.0/2490 is the administrative distance for EIGRP, and then we're going to have the feasible distance here that will show up in the route table. Feasible distance shows up in the route table. We see both the feasible distance and the advertised distance in the topology table. The administrative distance is 0 is directly connected, 1 is static. Again, I'm doing these because sometimes they show up. 90 is EIGRP. 110 is OSPF. And 120 is RIP. And then we had that one that showed up, what was 170 was the external EIGRP. So administrative distance, how trustworthy is the route? The ones that are directly connected is the most trustworthy. It always kind of bothers me that it trusts me to do a static route correctly more than it trusts the routing protocol to calculate the route. The topology table we looked at shows up again here. We have down here we have one successor, we have two possibilities, and we have the feasible distance 28,416, the feasible distance here, and then the advertised distance 2816. You notice for these that the advertised distance for these is the same as you would expect because they're on the same device, but the feasible distance is really quite different when we go through those things. And we have another one here, feasible distance 309. The feasible distance takes the best one, and these will be the ones that will show up in the routing table. The others will be in the topology table as they show up here as backup routes feasible successors. Let's see. We already did the tables here. This is just another slide. I found this one today. I thought it was kind of cool, but I forgot I had the other one in there. The neighbor table, next hop router, and the interface. This is what's going to show up in these things. The topology table, the network feasible distance, advertised distance, and then the neighbor. The best route then is going to go into the routing table. Once the routers initially share all of their information, they only update when there are changes, and that's one of the things that makes it different than some of the other routing protocols. OSPF was a changes also. And here we go again, the composite metric, and I think we've already looked at this. Bandwidth, the minimum bandwidth, the lowest bandwidth that we had, a gig, a 10 gig, and then 100 meg, it's going to use the 100 meg as the bandwidth, the slowest bandwidth. The delay, the delay is in tens of microseconds. You have to be careful in Cisco when it comes to time, and that's where the question mark comes in, at least to find out what the time units are, because this one's tens of microseconds. Sometimes we have minutes, sometimes we have seconds, sometimes we have microseconds. You gotta look at that to see what the time measure actually is. And then the delay, reliability, the likelihood of successful packet transmission, number between 0 and 255. 255 means 100%, 0 means 0 reliability. This is, again, that formula on how to calculate it. The K1 bandwidth, K1 times the bandwidth. K1 is equal to 1. Over here, the load, K2 times the bandwidth over 256 minus the load. Doesn't really matter a whole lot because we have a 0 here. So anything divided into 0 is going to be 0. So 0 times anything is 0, and 0 divided by anything is 0. The delay, the K3 is 1, and that's where we get the bandwidth, and the delay is what it actually uses. K3 is 1 times the delay is used, and then K4, K5 reliability, K4 and K5 are 0. So we have 0, and then whatever the reliability is, 255, even if it's 100% plus 0, again, is going to be a 0 in here. And K5 is 0. This section is considered to result in 1. EIGRP, it's a classless protocol, which means that we can subnet it. Cisco proprietary. Autonomous system numbers, which we change, which we assign, can be between 1 and 65,536. VLSM, we can use variable length subnet masks. It's considered a hybrid. And this one says hop count of 100. That's the maximum. The hop count that we saw in the show IP protocols was 100. It does support multiple protocols, which is not that big of a deal anymore. It used to be. We used to have IPX, a lot of IPX networks and some IP networks. IP, obviously, with the internet, is the protocol that we use today. So we have a number of labs here. Okay, so there is this other message in the hello message, a hello goodbye. I think there was a song like that. I say goodbye, or I say hello and you say goodbye, or something like that. Anyway, the goodbye message is designed to improve the convergence. It tells a system that I'm leaving. It's broadcast when an EIGRP routing process is shut down to inform the peers of the impending topology change, so that they don't keep sending hello messages and have to wait for the timeout in order to say, okay, this one is not available anymore. Synchronize and recalculate the neighbor relationships more efficiently. And the message, this is the message down here that is displayed. Neighbor is down, interface, goodbye, received. EIGRP v6, and we looked at it real briefly. Let me bring it back over here real quick. A couple of, and on this thing, these three routers in the middle that are the only ones that have the EIGRP v6 on them. So we have a neighbor is up, new adjacency, and that's when we were making some of those changes. And if we show IP protocols in here, we have routing protocol is EIGRP, and it's autonomous system 20. The summarization, all the things that we saw before, the K values, this is where you see the K values. They have to match before the neighbor relationships are going to form. This is one of the commands that you may need for the some of the stuff in the CCNA testing. Automatic summarization is disabled here. So, you know, newer ones, yes, auto summarization is disabled. Older ones, auto summary is enabled. Let's see if we can show IPv6 protocols. So IPv6 protocols, EIGRP10, we have the same K values, same hop count, same variants. The interfaces that it is enabled on and redistributing EIGRP10, which means that it is sending out EIGRP10 for that autonomous system, which is its updates. Notice that the maximum paths has changed dramatically. Up here for IPv4, maximum path was 4. Down here it's 16 for IPv6. The administrative distances are going to stay the same. If we do a show run, and I'm not going to go through the make you sit through watching the other configurations here. We go to the interface, we put an IPv6 address on it, we add the autonomous system to the interface instead of doing the network statement. You put the IPv6 EIGRP statement on the system itself, on the interface itself, and this auto config is when we do this. I have configured the network address, and auto config tells it to go figure it out and give itself an IP address. Auto config is one of the characteristics of IPv6. Let's see, clock rate here, because this is going to be the DTE on these things, and then the passive interface here on gigabit 00. For this one, it's not going to play in the EIGRP on that interface. The networks that we're advertising on it, and then for IPv6, we have to go in to do an IPv6 router EIGRP autonomous system number. We have to give it a router ID. This one's 1.1.1.1. Looks like an IPv4 address. It is the router ID for these things. All routers have a router ID. The EIGRP v4 just uses the highest loopback address, or it uses the highest IP address of any interface, but it uses some of the IP addresses that are there. And again, you have to give EIGRP v6 the no shutdown command to activate it. You get this out of the way. Will need to be directly configured on the interfaces over which it runs. Saw that in the show command there. To perform direct configuration, allow to be configured without using the global IPv6 address. Further, there is no network statement in an EIGRP v6. We still have to establish an IPv6 EIGRP instance. Differences: EIGRP for IPv6 requires a router ID before it can start running. We did that. Has a shutdown feature. We have to give the no shutdown command. When we use the passive interface configuration, IPv6 need not be configured on the interface. that is made passive. And what that's saying is, instead of trying to make a passive interface, just don't put the protocol on that interface. IPv6 uses the distribute list prefix list command to provide route filtering, and the route map command, which is something that we don't normally really talk about in CCNA, is not supported for route filtering with the distribute list. So that takes care of the EIGRPv6 lecture. A few troubleshooting slides, and when we get to frame relay, I'm not going to do frame relay because it's no longer part of the objectives. So, yeah. Okay. Am I back now? I guess that I have muted myself too when I figured out how to reshare. Anyhow, we'll do
now we can hear you.
Okay, we'll do these few troubleshooting slides, and when we get to frame relay, I'm not going to do them. Frame relay is not part of ICND anymore. So all of the frame relay, and I line the labs out, all of the frame relay labs, don't worry about it. They're kind of a frame relay is kind of cool. It's kind of a pain, but it gives testers the opportunity to ask a lot of questions. But it's not part of it anymore. But anyhow, point-to-point protocol, password authentication protocol, CHAP, challenge handshake authentication protocol. Any failure in the authentication process will result in the router interfaces being in an up-down state. The up state says that we have layer 1 is good. The down says that layer 2 not so good. So we're not making full connectivity. What we always want to see in that show IP interface brief is an up. Show interfaces, show PPP all. It says you'll be able to isolate and discover the root cause of why the interface is in an up-down state, and the show interfaces and the show PPP, point-to-point protocol. If we're using point-to-point protocol, it has to be configured at both ends. The Cisco default in the point-to-point protocol is a serial one. The Cisco default is HDLC, and all HDLCs are proprietary. Everybody's got them. Everybody's got their own, so they don't really cross over the way you would expect something like an Ethernet to do. The show commands used earlier do not help you identify the authentication problems, and then debug PPP authentication. Debug will show you in logging format every action that the router's taking. When you do it, you can debug all. The way you get out of debug is undebug, or you all undebug all. You can overload not only your own sensories, but you can overload the devices themselves if you try to debug too many things. So shut down the link and bring it back up to see the debug message, to see the three-way exchange, to see that you're actually getting the exchange for the authentication protocol. Port security. Secure addresses may appear as static entries in the output show MAC address table static command. Causes is if a secured VLAN associated with the MAC addresses is a regular or primary VLAN, the address associated with that VLAN may appear in the output. If it is associated as a secondary VLAN, the address appears in the primary VLAN in the output command. This is one that, yeah, you may have, but this is when we get the secondary VLANs. We have the primaries and the communities and the isolated arrangements. Previously configured static or sticky secure address on VLANs is missing. And this is talked about allowed VLANs on the trunk. And this is one that, are you going to do that? The answer to that's maybe. I don't know many times how many times you're actually going to change the VLANs allowed. But if it happens, the configured static secure addresses located on certain VLANs may be addressed by the software. be able to hot swap it out of the system, hot swap the interfaces out of the system. They're going to go away, and down there at the bottom line, the solution is you need to configure a secure trunk port with static or secure MAC addresses. That's going to then give us one of those. If you think back, the default was one address. You're going to have to do some other configurations with that. Another problem is listed in the table along with the cause of solution. Port security violation and shutdown mode, restrict mode are the ones that we can use. And what we say here, based on the violation mode, either the port will be error disabled or the packets from the unsecure addresses may be dropped if it's in restrict mode. The causes, and we're going into the security violation, too many IP addresses on this thing. Default number of configured MAC addresses that can be secured under normal conditions, we're probably going to be okay, but the list there, the same ones that I think we talked about when we talked about port security: virus attacks, hostile workstations, accidentally reconfigured hosts. Joe, the user, decides that he wants to put in a wireless access point because he wants to use his phone, I don't know, for whatever reason, put in his own switch and puts too many, and then puts too many MAC addresses on that particular interface. The solution to ensure the CPU is not loaded when such an event occurs, you need to set the violation mode to shutdown so that we're not trying to continuously just drop the packets. And configure error disable recovery, and error disable recovery is the configuration that will allow the switches to heal themselves when the violation is corrected, and that you have to do that configuration, how long you want to wait before that happens. OSPF troubleshooting, neighbors won't form. A number of things that could happen here. May not be configured on one of the routers, may not be enabled on an interface where it's needed. You have to advertise the interfaces that go out, that connect to other routers. You have to enable the protocol on it for it to participate in the dynamic routing protocol. Hello or dead timer intervals may be mismatched, and remember in OSPF they had to match. The IP OSPF network type mismatch on the adjoining interfaces, and that's to show IP OSPF interface. MTU mismatch between the neighboring interfaces. OSPF area type is stub, and again that particular one, you may see it, but that's beyond the scope of CCNA. The first time I ever saw that was in the CCNP studies. OSPF neighbors may have duplicate router IDs. You can, and I have said that the router ID will be the highest IP address that's on a loopback interface. No loopbacks, it's going to be the highest IP address that's on any interface. You can configure router ID using the router ID command, and if you use by accident the same one on two routers, then you can get into the problem here that they can't because of the duplicate IDs. They can't form the relationship. Isolate problems are listed in the table. OSPF may be configured on a secondary network of a neighbor, but not on the primary network. We can have multiple addresses on an interface when you're actually using the router. So we can have primary networks and secondary networks on these things, and then to show the IP OSPF interface, which will tell us which interfaces OSPF is configured on, or show running config. The show IP OSPF interface is kind of a quicker way to do it because you get the listing of the interfaces that you want to see. Hellos are not processed. The lack of resources show memory processor. we're overloading. Some of these dynamic routing protocols can take a significant amount of device resource. An underlying problem may be preventing the hellos from being received show interfaces, and that's kind of a catch-all. Yeah, show interface. Okay, let's see. Is there something wrong here with these things? EIGRP, show IGRP neighbor command does not list one or more of them. Are they on the same subnet? And this goes back to the one that Joel was talking about, being able to ping the adjacent router. Are they on the same network? Or do they have the same autonomous system number? And that's an easy mistake to make. The EIGRP neighbor authentication, and then that's a debug EIGRP package to be sure that the authentication is taking place. And then the K values must match. If the K values don't match, that will prevent it from forming. EIGRP v6 router does not have any route to a given subnet. The interfaces, check the routers. The interfaces are directly connected. A router will be able to have EIGRP IPv6 enabled on an interface before it can advertise about the subnet. Okay, so even if we're going to advertise an interface that's probably never going to be connected with anything else, we still have to configure EIGRP v6 on it so that it participates in the EIGRP party. Check the neighbor relationships. Has a route, but it appears to be the wrong route, suboptimal route, and that's the interface bandwidth and delay settings. Have they been changed? And it's going to use the lowest bandwidth because it will ignore the faster bandwidth. So you got to look at the path to see if the bandwidth is an issue when you go across those things, or if the delay is an issue. If somebody's gotten into the device and configured the interfaces to have a lower bandwidth or a higher delay, could be a problem. When the IPv6 EIGRP is an interface, subcommand is omitted. An interface that has no possible neighbors to it may be overlooked. Checked include, and this is the one that it's not being advertised. Be sure that you have the IPv6 EIGRP autonomous system number on it. Be sure that you have initiated the autonomous system number on those things. When you make an interface passive to EIGRP for the IPv6 process, and if potential EIGRP6 IPv6 neighbor is connected to the link, it will prevent the two routers from becoming neighbors. Check to be sure if you have passive interface. And again, what the earlier slide said, if you want to make an interface, a passive interface in IPv6 EIGRP, just don't put it on that interface. It won't participate then. But then if you come up with a one above where, okay, it's not showing up in the route table, be sure that the commands are there. And if EIGRP v6 isn't working in general, be sure that you've given EIGRP v6 the no shutdown command. These are the frame relay problems, which I'm not going to talk about because, again, it's not part of the certification anymore. And then there are another group of labs, troubleshooting labs. I want to go to the summary slide, and then I'll quit talking and you can work on labs for the rest of the night. Distance vector protocol advertises its routing table to all its directly connected neighbors. Distance vector is RIP, and then it adds the 1 to the hop count in RIP and then passes it on down the line. Slow convergence on these things. The link state protocol will make its routing decisions based on the state of the links, and they advertise, provide a lot of information, and typically they're not going to send their entire route table every 30 seconds like RIP does. IGRP sent its entire route table every 90 seconds. Slow converging ones. These link state protocols send changes. When changes happen, they send changes. And in OSPF and the Ethernet, we had the designated router and the backup designated router, which kept track of everything for us and updated everybody with them. You need to specify the interior routing protocols with a list of associated networks before the routing activities begin. Yes, when we go in there, router EIGRP 30, autonomous system 30, enter, and then we type in the networks that we want to advertise, the networks that we want to advertise that are on our router that we want to advertise to the rest of the world. One of the easy ways to see that list of networks is to do a show IP route command before you get into this, and you're going to get a list of the directly connected IP addresses. Those are the networks that you want to advertise. IGRP, no longer there, but could route IP, IPX, DECnet, AppleTalk. Versatility, it could route a number of different protocols. EIGRP can route other protocols also. Not such a big deal today because we're using IP on everything. Balanced hybrids driven by events rather than the periodic, and therefore help conserve bandwidth to real applications. It only updates the changes. The balanced hybrid was EIGRP. Switch network VLANs segregate devices into different collision domains and layer 3 subnets. Okay. VLANs segregate devices into different broadcast domains. Switches segregate them into collision domains, or bridges segregate them into collision domains. And then the troubleshooting frame relay problems. Again, we're not going to talk about frame relay. So with that, are there questions?